Welcome to the channel. My name's Robin Clevett. This is the Ultimate Garden Room series and we're just about to do our underfloor heating. We're having wet underfloor heating here, which works from an electric boiler. Now this is a very well insulated building. It's also fairly airtight. So all of that has an impact on our design. Now our design has been done by Nu-Heat. Nu-Heat are one of the UK's premier underfloor heating providers and renewables. I've been working with them since about 2008, 2009, when I did my first, what they call one zone system in a property in Richmond, South London. Ever since then, I've been using them for every single underfloor heating job that we've had in extensions, new builds and refurbishments. The systems vary very much. You have what we've got going on here, which is traditional in screed. We're using a liquid screed, and that actually, just as an aside, the liquid screed is fantastic at getting even more heat from the pipes because the liquid screed encapsulates the pipes, unlike a sand and cement screed which pyramids over the top and you don't get so much heat radiation through the solid mass of the screed. Anyway, so Nu-Heat have taken our area here. This is what they do. I give them the exact dimensions of all the areas. We talk about what the areas are, for example, shower room, sort of like living area, and they will work out all of the actual heat requirements based on what your uses are. They also take into consideration how well built the building is. In our case, this is really well insulated, fairly airtight, and in this room, there's not a lot of glass for heat to leak out of. And they will work out how many kilowatts of power that your boiler or your heat source will need to deliver to get you up to temperature. In this case, it's 5.7 kilowatts of energy that will heat this entire 80 or 90 square meters of space. That is going to come from an electric boiler, and that is in the plant room. So the first job will be to get the design, check everything off. We've got everything we need in here. We've got all of the pipe layouts. We've got all of the electrical schematics. We've also got all of the information about the manifolds, how it's going to go together. Boxes of clip track. This is the clip track. This is what we stick down to our slip membrane that goes on top of the PIR. This is what holds the pipes. This is a really nice system, keeps everything nice and true, straight and spaced correctly. We've got everything else here as well. So we're going to get on, prepare everything, put our expansion strips round, put our plastic on the floor, and then we're going to pipe this up, connect it back to the manifold, fill it with water, get it under pressure and test, and then we're going to screed. So this is what it looks like before I put the membrane down. The membrane goes on top of the insulation. It goes up the walls. Now I've put my expansion strip all the way around now. Now I'm going to use a black damp-proof membrane. So it's quite a thick one. This is 1000 gauge. And I'm going to lay that everywhere. I'm going to take it up and I'm going to just tape it to the expansion. So the screed will go in there. It's like a tanked system because the screed is liquid. It will encapsulate the pipes and form that really nice flat level screed. So my next job will be to undo this plastic, lay it all out, and then we can put the clip track in. The clip track is really straightforward as well. It's got a tape on the back, so it sticks itself down to this membrane. Now the key with it is keeping it clean. I've got to change the shoes in here, so my boots are over by the door because it's wet and rainy outside, and everyone who comes in, they just pop a different pair of shoes on and we keep it nice and clean. If you don't do that, it can look awful if there's site mud all over it and it just looks awful. The name of the game is keep it nice and clean, not too much grit and dust and mess, because when the screeders come in, if you haven't cleaned all that off, and it's quite hard hoovering in amongst those underfloor heating pipes, all of that will float through and pit the top of the screed. So that's it. Let's get on and get the membrane in.
So I proceed with the membrane, and it's something that you can do on your own. I mean, this is quite a big area, so you just got to do it in sections. I start by filling the small sections up, working into the big section, and then pull the big section through. You can see me there using a strip of timber. Now that sets the height I want to cut the plastic off. I also use that to push it into the corner, and then I can put my black tape on and holds it all back perfectly to that strip. And that little room there I'll obviously do independently. measure it up, roll it out, cut the plastic, and then I can just unfold it into the square sizes I need and set it into the rooms. It doesn't take a great deal of time, but it's super satisfying once you get it all finished and you know you're ready to get on with the next part of the job then. So but it's a job that's worthwhile doing well.
So the plastic membrane is all in, and we've got our expansion all the way around the edge, and everything's taped and tanked, which means that when the liquid screed is poured in, it will only stay the right side of the plastic, of course. Now this is quite an important part of the work. You really want to spend some care and time making sure, you know, you do this. Don't just throw it all in and expect it to be all absolutely perfect. I work with a lot of screeders who tell me, oh, what happens is sometimes it's not done properly, and then you start pouring the screed, it gets underneath and starts getting between the plastic and the insulation. And at that point, when you've got a few cubic meters of liquid screed coming in, that's the last thing you want. So take some time. It is a job that isn't just a labourer's job. This is a job that needs doing properly. And where we've even got our air vents, you see that we seal it all up. Again, expansion strip around those as well. So this is what the detail looks like. Expansion strip, plastic coming up, everything's taped together. So you can't really go wrong with that. Where we've got joins in the DPM, because obviously it only comes in 4 metre widths, and this is about 5 metres between these two walls, we use a tape, but I overlap them. So they're overlapped by a good ½ a metre or so. And then this is a proper tape for damp-proof membranes. So our first pair of pipes comes all the way through, passes through this wall, passes through this wall, travels around the outside, passes through that wall, and that is the circuit, or the underfloor heating circuit for this room. So each room is controlled individually. Then all of the other circuits come through, pass through from the plant room there, come across the top here, and then through and in. So it's fairly straightforward. Let's get it all piped up. Let's get some of this clip track down. It's a great product. It's got a self-adhesive backing to it, so this will peel off. Then it will attach itself down to the plastic. Now look, I've just literally dropped that on, and you know that's going to go off really nicely. We're going to get all those clip tracks in. Then we'll start piping it all up back to our manifold. So we've actually got some of the clip track together. Now Gary has been doing underfloor heating. He did my very first one that we did a good while ago. And it was also a Nu-Heat product. It was the first one I ever did. That was a Nu-Heat product. Now this is the clip track. Now Gary's already worked out. He's got his own drawing. You have a good method of working this out, don't you? So what do you do, Gary?
Basically, I just count the pipes because this is an accurate to scale drawing.
Yeah.
Of how many pipes will it take to cross the rooms. I work out how many pipes in each direction, and then I set the clips up ready to take that amount of pipes.
Yeah.
And then I centralise them in the gaps that are left.
Right.
You know, because now you've got plaster on the walls, the gaps are slightly different. So we space them out evenly. And once you've got all the clips set, it's just a matter of laying them at the spacing you require. We're going to start in this corner because it's the farthest outside and the furthest away from the manifold.
Yeah.
And it sets up our line down the side.
Of course.
Because we've got a few obstacles there with your MVHR and the door frame there. So it's easier to get the outside ones in first and then work towards the centre.
Excellent, let's do it.
Yeah, let's go for it. 8, 9, 13, 14, 15, 18, okay, so we chop that there. Yeah, because these probably don't span the whole width, but they do cut it. You just have to do it twice.
Yeah, so that's quite a nice idea. So that's just your pipe cutter. So this gives you the right amount of pipe. So all you've got to do is centre that up then, haven't you?
That's all I've got to do, centre it up. And we start about, say, 300 back from the end, because we've got enough room for the loop.
And this 14 mil pipe is quite flexible. It will bend.
It's flexible enough to get round that radius.
Yeah, it'll do a 150 radius.
Yeah.
Is they're rough. Are these 150 apart?
150 apart spacings, but it's all on the drawing.
Yeah.
It's very rarely anything else with Nu-Heat. It's normally 150s.
So we're going to centre that up to the room, obviously, and that's it. We line everything through that.
Yeah, that's where you've got to be careful. When you buy a cheaper version of underfloor heating, You think, well, that's cheap, I don't need as much pipe, but they might be 200 apart, and the heat output's not the same. So, you know, you get what you pay for. So.
Yeah, and that's another good point, actually. What people don't realise about underfloor heating is that sometimes they just go and put the pipe in everywhere. This is worked out.
This is calculated by computer.
Yeah.
I know the heat output from this, I know the heat the rooms are going to get. We have to protect the floor. So we're probably not let the floor go above 28 degrees. So we've got floor sensors in all the thermostats.
Yeah, so important that. Cause
not so much with tiles, but this is not tile, this is wood floor. So
exactly, yeah.
It's very important because engineered wood, well, you know more about floors than me. Exactly. You can't just heat them up.
No, I think there's a lot of problems with it. Yeah. And people watching this video probably say, yeah, I know all about that. So tell us in the comments if you've had issues with a floor covering and underfloor heating, because I'd like to sort of investigate why it was. Did you not have the heat sort of regulated enough for the flooring?
Well, the blending valve could have been touched, it could have been turned up.
Yeah.
And they told us that we need to have a very gentle heat. When we turned the blending valve down to 30, we found it made no difference. No. All the thermostats were satisfied easily.
Yeah.
So
yeah, and what that means is that because our house is quite well built, insulated and airtight, normally you'd run the system at what?
Well, normally 40, say 45, something like that, but even with tepid water going round, we found it easily heats the house.
So what you're saying is in this time of energy saving, if you can reduce the flow temperatures.
Well, we've got this system in the big build on a heat pump, and we know that it's running at very low temperatures. Yeah. Every thermostat, you popped in the other day, every thermostat was on 21 satisfied.
All satisfied, yeah. Brilliant, okay.
Yeah.
So the clip tracks fixed together, they're designed to slot together, which is quite useful, and they're quite strong as well. They don't snap very easily, so it's just a simple way of clicking together like this. That's really nice and secure. So let's take the scenario that I was going to glue these down. So I would peel that back, just turn it through 90 degrees like that, fold it off, and then when you're laying it down, you can put it exactly where you want it on your line. Okay, let's say I was running a row through here. It's on your line, and then you can just literally pop the end down like this. That will hold it, and then just take this from underneath, and then you bang on your line. So that's the easy way of doing it. So it's hard to see in this light, but all of the clip track is fitted. So this clip track, they're like rails. They're equally spaced, of course, to make sure that all the pipes are held nice and secure. Now, we've obviously put these down to suit our plan. That's why you see that there's some short ones running this way. They hold a certain number of pipes in a certain number of positions, and then they obviously all change direction, twist round, and do whole complete circuit. So when you're actually fixing this stuff down, it's best to keep them in line. So using a string line and a laser, you can actually keep them all in line. Now, a little tip is turn them over, peel back the tapes just enough that you can lay them back down in line and then pull the tapes from underneath. If you don't do that, what happens is you turn them over and they sort of grab straight onto the plastic wherever you are, and it's hard to move them around. Okay, you don't have to get them perfectly straight, but it's nice if you can keep them roughly in line and parallel. It just looks a lot neater.
After putting all the clip track in, we then start putting in the underfloor heating pipes themselves. Now, each circuit will have a different roll, and the rolls may say they're 100 meters or 110 meters, and they also tell you roughly what you'll be taking off. So it's all worked out for us. So what I like to do is I like to get the coil and walk round, popping them into the clips. Gary follows along, make sure they're nice and secure. It's a really straightforward job, but it's much, much easier if there's two of you doing this. You can see there that Gary's following along, making sure everything's in the right place. He's doing the bends, he's doing the radiuses, and he's clipping them as he does them as well. So it's one of those jobs that's so satisfying because you can get through quite a lot of work. What we're actually doing there is feeding them the ends of the coils back through into the plant room as well. So if you can take this one, for example, we're just going all the way through, bending, clipping, snapping them in, and then eventually we're going to get back towards the manifold position. And for us, we have to feed that through a hole under the door frame, across some insulation on the other side, through another wall and back into the plant room. So it is really a job which is much more suited to two pairs of hands. Indeed, I have seen Gary do this on his own, but it's much nicer if you work as a team. You can just see there, I'm out the way, I'm pulling the pipes round. Gary can work out all the set positions that he wants and eventually get us all the way back, as I say, to his manifold. Now, we don't connect the circuits to the manifold until we've got all the pipes in. Then Gary can do them all in one go, but we'll come on to that a little bit later on in this video, where we do actually connect them up to the manifold. There's Gary feeding it under the door. I'm in the plant room, gently pulling it through there.
So the underfloor heating is a fairly straightforward job. Here are the fundamental things that you need to get right. So when you send off for a plan for your underfloor heating, you need to make sure that you give them the exact room dimensions as built. Don't send them the architect's drawings if you've then gone and changed the positions of the walls, because this is really going to throw out the whole design. And I can't stress this enough, that if you get that wrong and you come and start pulling loops in, you may find that you get trapped and you can't get back to the manifold, or you've got a really big loop. What we're trying to aim for is that the circuit, so in this main area, we've got 3 sets of loops, if you like. We've got 3 lots of pipes and they go back to the manifold, but they're all on the same actuators, so they all work as one. If one's 20 meters long and one's 80 meters long, it's quite difficult to balance the heat coming through the system, as far as I understand it. So there we go. So get your drawing in, make sure it's exactly right to within a few millimeters if you can, and then the design of the system is perfect to that as well. So we've got 1 circuit left to go. Now let me grab some of the pipe. Now this is the pipe. It's 14 millimeter. It's designed especially for underfloor heating. It's designed to be encapsulated in screed, so it doesn't get affected by cement or anhydrite in my case. So it's absolutely perfect. It's quite stiff, and you'll see that when we're moving along, I have to sort of keep turning it over, pulling it backwards and forwards, and Gary's having to go around and clip the ends down as well. We'll probably go around afterwards and make sure that the system's held down. But once it's full of water, obviously you have the weight of the water, and then when the screed comes in, because there's water in the pipes won't try and float to the top of the screed, and that's pretty important. So if you do not fill it up with water and you put your screed in, especially if it's a liquid screed, it has a tendency to want to float to the top, because air will sort of want to float to the top, even the air in the pipes. So we're going to get this in now and start doing the last of the system. Then we're onto the manifold. Now you can see that there's a strange arrangement over here. Now the reason for this arrangement is because I've got a feature screen which is going to be fixed to the floor. So we want to avoid that screen. It's actually marked out. It's raking, it's in an arc. And that is where it's going to be, the screen. So we obviously have to avoid it, so I can actually fix down through the screed. So this is the last of the loops. They've all worked out absolutely perfect. On the drawing, it tells you how many loops you're going to have of pipe, or how many coils, and it also tells you how much you'll be cutting off the end. So it might be a 110 meter coil like this one, and it might say on the plan that you should be cutting 13 meters off at the end. So providing that's what you cut off roughly at the end, you know you're somewhere in the right ballpark. But let me tell you, if you want to know how do I know, all of these pipes are marked up with the meters all the way to the end. But that's really helpful as well. So how do we know that we're going to have enough heat coming from an underfloor heating system? So it's really important that the fabric of the building is built as per building regulations, okay? So that means it's insulated well and it's fairly airtight, and all the ventilation is also the correct type of ventilation. Then we send off our plan to Nu-Heat. We tell them how it's built, what insulation we've got, how many external windows we've got. They work out the heat loss, and then they come back with a system that will provide exactly the right amount of heat from the smallest type of heat source. For example, we're only using a 6 kilowatt electric boiler, and this requires 5.7 kilowatts of power. That's when it's all on, if you like. But quite often with underfloor heating, it comes on, they're thermostatically controlled, so you might not be calling for all that heat because some rooms are staying warmer than others, for example. But it's important that you work it out. It's no good just buying a system, putting it in, and not having an accurate calculation of the heat loss and how much heat you need to heat the room. So this is what the manifold is looking like now. So there's some of the pipes coming through from one point, and then there's the other pipes which run through down the side of the unit into the other area. There's one more connection to make up. Gary's going to show us exactly how that's done. So just, it looks so tidy now compared to a minute ago when all the pipes, because we just pull them through enough, don't we?
Yeah.
How do you actually cut this stuff?
Well, just with normal pipe cutters. It's only plastic pipe, just snip.
All right, okay.
Simple. You get a nice flat cut.
And that's really important.
That is important because I've cut this one to length. You get an insert, brass
Have a
insert.
look at that.
So you get a nut and olive. Okay. And you get a brass insert. I've put a little bit of silicone grease around it. It goes in easy because it's quite tight actually.
Right.
But you want to go right in up to the hilt. So
And that
on
goes
there.
down,
Like that.
look at that, right down the
that,
end of that.
tight.
That's a nice connection, isn't it?
Yeah, then when you get that on there, okay, that's wants to hold in there.
That is a beautiful.
Just get that up there.
So that really stiffens the end of that pipe up, doesn't
okay.
it?
And then get that in there. And as you tweak it up, the Oliver grip.
It's a lovely connection, isn't it?
It is, yeah. Let's just get on that. So you're right on it there.
And doesn't it look lovely and neat?
Well, when it's tidied up, get it back to the wall. And these formers, because this is quite a tight bend, without the formers it's hard to get them to stay there. So you really need them formers on because you know it's quite a tight radius there, and it keeps them nice tight back to the wall.
So now, what's the process now? You've got it all there.
Well, basically you've got the valves off here, so we're only interested in the underfloor heating. So we're going to connect an hose to the flow connection here.
Yeah.
We're going to connect a hose outlet to the garden there.
Yeah.
I've opened all them up. There's a locking nut there.
What are they called?
These are the flow regulators. So
Yeah.
you take the locking cap off, loosen off the black cap, and these will be done when I commission it to get the right flow rates.
Right.
In the folder you get, I know the flow rates because you've got a tiny loop in the bathroom, you've got longer loops in the main room, so you know a different flow rates, so it's all balanced up.
Yeah.
And then this locks it in. So at the moment these are all fully open.
Okay.
These are where the actuators go.
Yeah.
And these caps, what you do is just screw them down, hold the pins down, which is off. When the pins are up, they're on.
Okay.
So you want to hold them all off.
Yeah.
Okay. Bar one. So this one are open. I'll remove this one. I'll get all these screwed down.
Yeah.
And then I'll let water in, and it'll just go around this one loop.
Okay.
And then I'm trying to dispel all the air because it's one of the main problems underfloor heating. You've got to get the air out.
Right.
And I'll let that run maybe 15 minutes while I muck about with something else.
Yeah.
And then if you put it into a bucket, you can actually see the bubbles coming out. But I mean, 5 minutes, 15 minutes, it's definitely all gone.
Depending on how big the circuit is.
Well, you can't have much more than 100 metre runs in a loop because, you know, you can't go on forever with a loop. So, you know, I think it says in the book 5 minutes. I always give them about 15 while I'm doing something else.
Yeah.
Get each, so I'll do that one, then I'll cap that one off, open up the next one, and I'll do every single loop. And then when you've done that, you pressurise it. Okay, so you turn off the outlet, the drain, so now it's filling. You pressurise it to about 5 bar. Leave that overnight for testing purposes. And then in the morning, we're going to drop that to 1 bar because they're screeding it the following day. You just leave a bar in it when they screed it.
Okay, and the idea is twofold. You want the pipes full of water, so they're under some tension. Do you?
Yeah, and pressurised because, you know, we don't want no movement. That's it, solid.
And then B, you want to make sure there's no leaks.
Exactly, yeah.
Okay.
I mean, there shouldn't be. There's no joints anywhere, but you know, that's not to say someone hasn't dropped a tile on one of them in there. I know there's no tiles in there, but anyway, someone could have hit one and not told us. But
brilliant. So that's all finished now.
We're just I'm gonna go through and do
in.
these, put some water loop by loop. You know, I've got the hoses ready. I'm just going to cap these ones off, and then I'll commission them one by one.
Perfect.
And then leave this under pressure overnight.
Yeah.
Coming in the morning, obviously we have a visual tonight, but coming in the morning to make sure the gauge has only dropped if anything, half a bar. You'd expect half a bar sometimes with bits of air in the system, but you know, you're going to see it because we're the only people here. It can only be here, so.
Yeah, exactly. Yeah, because the pipes are continuous.
I mean, these joints very rarely leak. You've got rubber washers on the pump valves. If that's tight, they're tight. Rubber washers there, washers there. I mean, it's not. You know, it's very rarely leaks.
It's a lovely looking bit of kit.
Yeah, and you've got 2 temperature gauges. These are in a dry pocket, so you can actually pull them out.
Okay.
That's a dry pocket, but
Right.
yeah, you can see what the flow temperature is and a return coming back. It gives you a good indication.
Brilliant.
I will mark up all these to what zones they are.
Yeah.
For in case, you know, someone else comes here, they like to know what's happening. And I'll mark it on the top here. So zone 1 might be, I don't know, bathroom, whatever. Just so they know. And if you look in the folder, you've got a drawing of every single bit of pipe we've run, so they can tell what's not heating, what's heating, and
Brilliant.
you know, it's just very nice bit of kit, really.
Yeah, they are. They're superb, aren't they?
Yeah. And these here, these caps here act as the on-offs. I mean, if you can get one off. So if you take the cap off, we're going to put the little brass hose connections in, the same as tap connectors on the end there.
And they're
the on-off. So if you clip that, if you get that square locating like the drain cockpit,
oh, I see.
that
so
can turn it on and off. So that's actually now on and off.
that's brilliant. Let's get it filled up.
Yep.
Okay, Gary, so that's it. We're all done.
Yeah, it'll be under test tonight, and that's it. We just wait until the screeders are finished.
Excellent. Thanks so much, mate. Good job.
Thanks.